Now we are going to an interesting result. That is, if the series, consider two series, sigma xn that converges to x and sigma yn that converges to y, then what about sigma xn plus yn is converges to x plus y? The next theorem of the result deals with that. When two series converges to two distinct points, then the sum of the two series converges to the sum of the two limits. That is, if sigma xn converges to x and sigma yn converges to y, then sigma xn plus yn converges to x plus y. This is the theorem. How to prove this one? So its proof is, let Sn be the nth partial sum. Sn be the nth partial sum of sigma x and Tn be the nth partial sum of sigma yn. Sn be the nth partial sum of sigma xn and Tn be the nth partial sum of sigma y. Now listen, we know that sigma xn converges to x. This given sigma xn converges to x. That means its nth partial sum Sn also converges to x. Sigma yn converges to y. That means its nth partial sum Tn converges to y. Okay. Now, sigma xn plus yn. What is sigma xn plus yn? Sigma with respect to n, xn plus yn equals, it is x1 plus x2, sorry, x1 plus y1 plus second term x2 plus y2 plus etc. plus xn plus y. Okay, that equals, it is x1 plus x2 plus etc. plus xn plus y1 plus etc. plus y. That means, what is x1 plus x2 plus etc. plus xn? That is the sum of the first n terms, means which is nothing but the nth partial sum of the series sigma xn, that is nothing but Sn, plus what is y1 plus etc. plus yn? So which is nothing but the nth partial sum of the series sigma yn, that it will be Tn, Sn plus Tn. But Sn converges to where? Sn converges to x, and what is Tn? Tn converges to y, then Sn plus Tn converges to x plus y. So that means sigma with respect to n, xn plus yn converges to where? X plus y. That is what we require here. So when sigma xn converges to x and sigma yn converges to y, then sigma xn plus yn converges to x plus y. Here, since sigma xn converges to x, Sn be the nth partial sum of sigma xn, Tn be the nth partial sum of sigma yn, then sigma xn converges to x means Sn converges to x. Why? Because we know that the series converges, then its nth partial sum converges to the same point. When given sigma yn converges to y, surely its nth partial sum, that will be Tn, that converges to y. Now, can consider sigma with respect to n, x and y. That is x1 plus y1 plus x2 plus y2 and so on. You can associate this one in this way. So finally it is, the first bracket is nothing but Sn. Why? Because it is the sum of the first term, n terms in sigma xn. And the second bracket consists of with the sum of the first n terms in sigma yn. So this is xn, this is Tn. But we know that Sn converges to x and Tn converges to y. So Sn plus Tn converges to x plus y. So finally, sigma with respect to n, xn plus yn converges to x plus y. So this is the proof of that result. So now listen, Suppose sigma xn converges to x. Then what is sigma c into xn? Sigma c into xn. Is it converges to cx? Where c is positive. Where c should be positive. How? By the same argument. We know that Sn, what is Sn? Sn be the nth partial sum of sigma xn. Then sigma xn converges to x means this Sn converges to the Sn converges to s. Since c is a positive quantity, so sigma Sn converges to where? C into Sn converges to cx. So finally, sigma cxn means it is c1 x1 plus etc. plus cn xn. So it is nothing but cxn plus etc. plus cx1 plus etc. plus cxn. That is c into x1 plus etc. plus xn equals c into sn. But c into sn converges to cx. Therefore, sigma cxn converges to cx. Okay. Now we are going to another important result, that is nth term test. This is an important result. That's a very important result. It's a crucial result regarding the series. Nth term test. What is nth term test? That theorem states that if the series sigma xn converges, then limit xn equals 0. If the series sigma xn converges, any series, if the series sigma xn converges, then limit xn equals 0. This is the nth term test. So, if limit xn equals 0, need not be implies sigma xn converges. Its reverse inclusion need not be hard. But here, the nth term test states that is, tells us that if sigma xn converges, then limit xn equals 0. How to prove this one? Sigma xn converges. So for, let sigma xn converges to x. Why? Because it is given sigma xn converges. Let Sn be the nth partial sum. Nth partial sum of sigma xn. Sn be the nth partial sum of sigma xn. Since sigma xn converges, we know that a series converges, then its nth partial sum also converges to the same point. Sn converges to x. But what is Sn here? Sn equals x1 plus etc. plus xn. Okay. What is Sn minus 1? That is the n minus 1th partial sum of the series sigma xn. So that is x1 plus etc. plus xn minus 1. Xn minus 1. So what is Sn minus 1? That equals term by term subtraction, vertical subtraction, x1 minus x1 etc. cancelling each other. What remains there? Only xn. Okay, all the other terms are cancelled. Now taking limit on both sides. So it is limit Sn minus 1 equals limit of xn. That implies limit Sn minus limit Sn minus 1 equals limit xn. What is limit Sn? We know that since sigma xn converges, its nth partial sum also converges to the same point. That sigma xn converges to x, so Sn converges to x means limit Sn equals x. Limit Sn equals x, also limit Sn minus 1 is again x. Why? Because of the convergency. If limit Sn minus 1 converges to another point, then it should be diverges. So since it is converges, limit Sn and limit Sn minus 1 are same. So finally this is left side is 0 means 0 equals limit xn means limit xn equals 0. So this is the important result. If that is the nth term test. If a series converges, then if a series converges, If the series sigma xn converges, then limit xn equals 0. Sigma an converges, then limit an equals 0. Agree? What about its reverse inclusion? Limit xn equals 0. Limit xn equals 0. Is it implies sigma xn converges? This does not imply sigma xn converges. Why? Take an example. Consider sigma 1 by n. Consider the series sigma 1 by. Here what is xn? Xn equals 1 by n. So what is limit xn? Limit xn equals limit 1 by n. What is limit 1 by n? When n goes to infinity, limit 1 by n equals 0. But we know that sigma 1 by n diverges because of the pth term test. That is sigma 1 by, we know that sigma 1 by n power p. We will discuss it later. Sigma 1 by n power p converges if converges only when p greater than 1. And it diverges if 0 less than or equals p less than or equals 0 less than p less than or equals. So this is the pth term test. So here limit 1 by n equals 0 means limit xn equals 0, but sigma 1 by n does not converge. So the nth term, the reverse inclusion of nth term test does not exist. So the nth term test states that when sigma xn converges, limit xn equals 0, and if limit xn equals 0, that does not implies sigma xn convergence. Okay, thank you.